Okay, so we're going to perform this fairly simple integration. Integral of 2 plus 5x squared with respect to x. Looking at that, 2 is a constant, integrated constant, it always becomes the constant times x. So that's simply 2x. 5x squared, we apply the normal rule for integration, which is that you increase the power by 1, so squared becomes cubed, and you divide by the new power, so divide by 3. And always add plus c as well. We could tidy that up, you'd probably get the marks for that, but it doesn't look that nice having the 5 and then a fraction just written next to each other. So I'm going to write 2x plus 5x cubed over 3 plus c, and we're done. Okay, so this is a C1 question, and you're not expected to know the factor theorem or remainder theorem for C1. So if you see a cubic to factorize, chances are it'll be fairly straightforward and it'll be a bit like this one. Okay, so looking at this, we can see that both terms have x as a factor. So the first thing we can do quite easily is take x out. So x times x squared minus 9. Okay, you can check for yourself that that expands back to give what we started with. And here, this is crucial, you should be recognizing the difference of 2 squares. So that whole bracket can become x plus 3, x minus 3. So in those 2 steps, we have factorized that completely. Okay, hello, this is a fairly straightforward and standard C1 transformations question. We're given a curve, y equals f of x. We don't know the equation, but we don't need to because we know the key points, which is its shape, where it crosses the y-axis, and its minimum point. So we just need to see what happens to those. So for part A, when we replace y equals f of x with y equals f of x plus 3, well, all the y values have been increased by 3. So that means the whole thing shifts up by 3 units. So instead of crossing at 0.7, it's going to cross at 0.10, somewhere up here. And instead of having a minimum point at 7.0, it's going to have a minimum point at 7.3. Now my tip for you when drawing these is don't mark all the points first and then try and get your smooth curve to cross through them, because that can lead to difficulties. So instead, simply draw the curve roughly where you know it should be. Hopefully you do a better job than that. And then mark on the detail of what the points are. So this point here, instead of 7.0, that's 7.3. And this point here, instead of 0.7, that's 0.10. Oops, bit of a bad 0 there. Moving on to y equals f of 2x. When you have a constant inside the bracket, so multiplying x, that means it's a stretch parallel to the x-axis, and this is the one where it sort of does the opposite to what you'd expect. The 2 in there means that it's going to be stretched by a scale factor of a half. So anything which is on the y-axis is going to remain the same, so it's still going to cross here at 0.7. That remains the same, but anything away from the y-axis is stretched by a scale factor of a half, so it becomes closer to the y-axis. So rather than crossing at 7.0 here, it's going to cross somewhere down here. Now again, don't mark the point first, just draw it and then mark the point on afterwards. So something like this. And I can mark this point as being 3.5, 0. Other things to remember, don't forget, label your axes, x and y, x and y. Try and get your curves as smooth as possible. You're not doing it on a computer, which is good news for you. Get them as smooth as possible, but the key is labeling the detailed points and getting them right. And we're done. Okay, so we're going to differentiate this function. For part A of this question, we just simply differentiate to find f dash of x. So 3x, any constant times x just differentiates to that constant, so that gives me 3 x cubed. Follow the normal rule, bring down the power in front and then reduce the power by 1. So x cubed becomes x squared. Okay, that's fairly straightforward. Part B, we're given that f dash of x equals 15. So this equals 15. And therefore we can find out the value of x. So this is going to be a quadratic equation. So 3 plus 3x squared equals 15. Any number of ways to rearrange this. I'm going to start by subtracting 3. So 3x squared equals 12. Divide by 3, x squared equals 4. And therefore x equals plus or minus 2. So we're square rooting both sides in that last step. Don't forget the plus or minus. The alternative route is if we had 3x squared minus 12 equals 0. You could then also divide by 3, so x squared minus 4 equals 0. And this factorizes as the difference of two squares, your best friend in A-level maths. X plus 2, x minus 2 equals 0. And again, from that you get the solution x is 2 or minus 2. However, the detail, okay, the devil's in the detail. X is greater than 0, we're told, so my solution is x equals 2. Probably wouldn't lose a mark for having plus or minus 2, but 2, positive 2 is the answer. Okay, this one, a C1 question on sequences, and we're given a first term of the sequence, and we're given this formula for how to get the terms after that. And this tells you that to get the n plus 1th term, you look at the nth term, so the one before, you multiply it by a, and you subtract 3. So let's have a look then. Part A, we're asked to find the second term, so x2. So using the formula above, x2 is going to be equal to a times x1 take away 3, which turns out to be a times 1 minus 3, which simplifies to just a minus 3. So that's my answer to part A. Part B then, show that the third term x3 is that. So using the same formula again, x3 is going to be a times x2 take away 3. Okay, so we just put in what we have for x2 from part A, we put it in there. So a times a minus 3 take away 3. And we just have to tidy that up and multiply it out. A squared minus 3a minus 3, and that is what we were required to do. Part C, we've got some extra information here. We know that the third term is equal to 7. So this term that we just worked out, which is this here, is equal to 7, and we want to find the possible values of a. So we've got a quadratic here, a squared minus 3a minus 3 equals 7. So we've got to turn that into a quadratic we can solve into the usual format. So a squared minus 3a, we take away 7 from both sides, so minus 10 equals 0. We're looking to factorize that. So in the usual way, we want two numbers that multiply to give minus 10 and add to give minus 3. So they've got to be one positive, one negative, factors of 10 that are 3 apart. So factors of 10, 1 and 10, that's no good. 2 and 5, that ought to do it. So we're looking at a minus 5 and a plus 2, and that equals 0. So from that quadratic, either this bracket is 0, which gives me a equals 5, or this bracket is 0, which gives me a equals minus 2. You'll see that I've switched seamlessly to x here, which is a common mistake, or common for me, so try to avoid that. Use the actual variable that you've been given, so a is 5 or minus 2. And we're done. Okay, drawing this on the computer is not going to be easy, but we'll give it a go. So we have a reciprocal graph, and a straight line, and we've got to sketch them on the same axes and make sure we show points of intersection with axes. Okay, so starting with the easy one, the reciprocal. All reciprocal graphs look the same unless there's a minus sign. They look something like this. It's a bit high at the bottom, but it'll do for now, and that's a better drawing there. So that's the shape of a reciprocal graph, and they look the same, it's just the scale that's different, and there's no scale on this yet, so that's fine. Now to plot a straight line, you should be able to do that. We know it has a gradient of 2, so that means along 1 up 2, and y-intercept of 5. So I'm going to pause the tape and do this a cheaty way. Ta-da! There we go. It's hard to draw graphs, straight line graphs on this computer, so I did it a cheaty way. So anyway, label the points where it crosses the axes. So this is the y-intercept, which is at 5. The only other point here is this one. So we're looking at the point where this graph crosses the x-axis, which is when y equals 0. So if we come back up here, it's when 2x plus 5 equals 0. So 2x would equal minus 5, x equals minus 5 over 2. So that's the x value that we need for down here. So the point is minus 5 over 2, we could write minus 2.5, and y value obviously 0. That's that one there. So we've marked all the points there. We can see that these two intersect at 2 different places, and that's what we're going to be finding out in part B. Oh, and don't forget to label the graphs that you've drawn. So for part B, we want to find the points of intersection of these two lines, and whenever you want the points of intersection of two lines, you do it by solving them simultaneously. And we can see from the graph that we're going to get 2 solutions, one in the top right quadrant, the other in the bottom left quadrant. You can go back and look at that. So we know what to expect. And the easiest way, because these are both in the form y equals, the easiest way to do it is to equate them. So if we equate these two now, we get 2x plus 5 must equal 3 over x. We know that we're going to get a quadratic because we know that there's 2 solutions. It doesn't look like a quadratic now, but if we multiply through by the x to bring this up to the other side, then we're left with 2x squared plus 5x equals 3. 2x squared plus 5x minus 3 equals 0. Now that is an ordinary quadratic. Now we're going to look to see if we can factorize this, and different people have different methods for factorizing quadratics with a number in front of x squared other than 1. My method is to take a and c and multiply them, work out what that equals. So ac equals minus 6, and also to note what b equals. So b equals 5. And we look for 2 numbers which multiply to give minus 6, and they add to give 5, and those 2 numbers would be 6 and minus 1. So then I rewrite the quadratic, 2x squared, replacing the 5x term with plus 6x minus x. So that's using the 6 and the minus 1 from here, and then I've got my minus 3, that equals 0. And then I factorize each part separately. So here, the first part, 2x squared plus 6x, I can take 2x out of both of those. So that's 2x times x plus 3. And I know I want to have the same bracket here as I'm going to have here. So to have x plus 3 here, I just have to have minus in between, and that's effectively minus 1. So there's like a 1 there. And so the 2x from here and the minus 1 from there give me my other bracket. So 2x minus 1, x plus 3 equals 0. So that gives me my 2 x values. So x is either, well, if this bracket is 0, then x would be a half, and if this bracket is 0, then x would be minus 3. So I'm almost there, but I've got to find the y values because I need the coordinates of the points of intersection. So to get the y values, I just need to substitute the x values that I've worked out back into one of my equations. It doesn't matter which one. So you pick the simplest. So I'm going to sub into y equals 3 over x and see what I get. So when x equals a half, y equals 3 divided by a half, which is like 3 multiplied by 2, so y equals 6. And when x equals minus 3, then y would equal 3 divided by minus 3, which is minus 1. So finally we give our coordinates for the final answer. So the points of intersection are at a half, 6, and minus 3, minus 1. There we are. Okay, C1 question on sequences is an arithmetic sequence because she starts running 5 kilometers and then it will be 2 kilometers more the next time, so it'll be 7, then it goes up by 2 each time. So we can treat it as an arithmetic series with first term A equals 5 and common difference D equals 2. So for part A, we want to know, well, we want to show that she runs 11 kilometers on the 4th Saturday. So that's basically saying show that the 4th term in the sequence is 11. You can do that using the formula for the nth term, but actually the simplest way is just to say that 5 plus 2 on the 2nd day plus another 2 on the 3rd day plus another 2 on the 4th day equals 11. That's all we need to show. Part B, find an expression for the length of her training run on the nth Saturday. Well, that's basically your nth term of an arithmetic sequence. So un equals a plus n minus 1 d. So for the nth term, in this case a is 5, so 5 plus n minus 1 times 2. That's basically your answer, but we might as well simplify it. So 5, if you multiply out the brackets, plus 2n minus 2, so we get 2n plus 3. Okay, part C, show the total distance she runs on Saturdays in n weeks of training is n brackets n plus 4. That is your sum of n terms. Okay, so it's saying if we add up all the runs for the first n weeks, what do we get? So the formula is n over 2 times 2a plus n minus 1 d. So again, this is for the nth term, so we don't know what n is, so just leave that as n over 2. Inside the brackets, 2a is 2 times 5, and we have plus n minus 1d, so n minus 1 times d, the common difference of 2. We can see here that 2 is a factor of both the terms inside the bracket, and the term outside the bracket is divided by 2. So those things cancel each other out. So they can all just go, so we're left with n brackets 5 plus n minus 1. And 5 plus n minus 1 is 4 plus n, also known as n plus 4. So n brackets n plus 4 as required. Part D, we're told that a particular term in the sequence is 43 kilometers, the nth term for a particular value of n. So we use the formula that we've already got for the nth term. Okay, the nth term is this, 2n plus 3, and we say, well, 2n plus 3 must equal 43 in this case. So 2n plus 3 equals 43. Therefore, 2n equals 40, and n equals 20. Last of all, the total distance that she runs on Saturdays in n weeks of training. Well, this question is slightly ambiguous because it refers to n weeks of training, which is a general term. What it really means is the n that you just found out, that particular value of n. So it wants the sum for the first 20 weeks. So we want S20. Okay, we know that Sn is n brackets n plus 4. We work that out here. So S20 is 20 times 20 plus 4, which is 20 times 24, which is 480 kilometers. Okay, so we have a quadratic here in which some of the coefficients contain this constant q, and we're told that there are no real roots, no real solutions to this quadratic. So part A, show this inequality to be true. Well, when you see an inequality like this, it's going to be using the discriminant, and that brings in this fact here. So no real roots, that means we can't solve it. Imagine doing your quadratic equation via the formula. You'd have to square root the discriminant, and if you can't square root the discriminant, you can't solve it. So that means if it's negative. So we're dealing with a discriminant b squared minus 4ac being negative. It must be less than 0. In this case, my a is 2q, my b is q, and my c is minus 1. So if we go ahead and substitute that in, b is q, so that becomes q squared minus 4 times a, which is 2q, times c, which is minus 1, and that's less than 0. The minus signs cancel out, and we're left with q squared plus 8q is less than 0, and that is what we wanted. So that's part A. Part B, find the set of possible values of q. We have to solve this inequality. Step 1 of that is to find the critical values. That's basically like solving a quadratic equation. So if we look at it now, q squared plus 8q is less than 0. Factorize that just like you would an ordinary quadratic, and this is an easy one. Q brackets q plus 8. And this, in the same way as with the quadratic equation, this factorized form gives me my two critical values. So this one gives me q equals 0. This one gives me q equals minus 8. Now if this were a quadratic equation, that would be the end of it, but it's an inequality, so I need to know how do those critical values define my possible region, my range of values for q. Is it all the values between 0 and minus 8, or is it the two ranges of values either side of those? Well, to answer that, we think about the shape of this function. If we were to plot it as a graph, it has an invisible plus sign here. It's a positive coefficient of q squared, so the graph of it would look something like that. It would be a smile shape, and the solutions to the quadratic equation where it's 0 are 0 and minus 8. Okay, so and we've got an axis here. So these are my critical values, and I want the region for which this expression, the whole of this expression, is negative. It's less than 0, which in terms of the graph means below the axis here. So I want to describe this region here, and that clearly is between minus 8 and 0. So my solution, written as a simple inequality, is that minus 8 is less than q, which is less than 0. Done. Okay, we have y as a function of x. It's a polynomial, something which we know how to differentiate. The only thing that slightly complicates it is that we have k as a constant there, but that doesn't really make it too tricky. So we're going to go ahead and have a go at this. Part A is to differentiate. Find dy by dx. So let's do that. The first term, constant, just sits there, pays attention and watches, and then we see what happens to the x cubed. We bring the 3 down and we reduce the power by 1. So k times 3x squared. We'll rewrite that in a minute. X squared becomes 2x, bring the power down and reduce the power by 1, so the new power is just 1. X becomes 1, and the minus 5 disappears. So The only bit of tidying we need to do is to sort this out. So write it as 3k x squared minus 2x plus 1. Now, part B, we're given a bunch of information. I have to figure out what's relevant and what to do with it. So point A has x coordinate minus a half, and it lies somewhere on the line C. And if we do the tangent to C at A, it would be parallel to this other line that we're given. So if we boil that down, what that really means is we're given the x coordinate of a point on the curve, and we're given the gradient of the point on the curve, because the gradient will be the same as the gradient of this one. And the gradient is given by this formula. Dy by dx gives you the gradient. So that's the link. So first we need to know what is the gradient of this line here, and to do that I'm going to just rearrange it. So first of all I can write 2y equals 7x minus 1, and then divided by 2, y equals 7 over 2x minus a half. So the important thing in here is the 7 over 2. So the gradient of that line there must be the same as the gradient of the tangent at A. So that must also be 7 over 2. So what that means is at A, dy by dx must equal 7 over 2. And that's how I find out the value of k. So dy by dx from above is 3k x squared minus 2x plus 1. And I'm saying that that must equal 7 over 2 when x is minus a half. So 3k times minus a half squared minus 2 lots of minus a half plus 1, that equals 7 over 2. Minus a half squared, well, a half squared is a quarter, so is minus a half squared. So that's 3k over 4. Minus signs cancel in this term. 2 times a half is 1, so we've got plus 1 plus another 1, so that's plus 2 equals 7 over 2. So 3/4 k equals, well, 7 over 2 take away 2 is 7 over 2, take away 4 over 2, which is 3 over 2. So here the 3's on top, we can divide by 3, both sides they cancel. So all we need to do now to get k is to multiply by 4. So k is 4 over 2, which is 2. Finally, part C, we want to find the y coordinate of point A. Well, the x coordinate and the y coordinate are linked by the original equation. Y equals kx cubed minus x squared plus x minus 5. But now we know that k is 2. So they're linked by y equals 2x cubed minus x squared plus x minus 5. So to find the y coordinate of A, we use x equals minus a half. That's the x coordinate of A, and we substitute it in there. So we get y equals 2 lots of minus a half cubed minus a half squared. Remember your brackets here and be careful with them. Plus minus a half, oops, minus 5. Hopefully that didn't cause too much of a problem. So just have to tidy that up. Minus a half cubed is minus 1/8. So 2 lots of minus 1/8. Minus a half squared is plus a quarter, but we're subtracting it, so it's minus a quarter minus a half minus 5. So 2 lots of minus a quarter, sorry, 2 lots of minus 1/8 is minus a quarter. So minus a quarter, take away another quarter, take away a half, that's minus 1. Take away 5 from that, it's minus 6. And there is your answer. Okay, we have this lovely diagram to help us, and we are told that points Q and R lie on L1, and that's shown in the diagram, and that these are their coordinates, and we want to find out A. It tells us the length of QR is A root 5, and it wants to know what A is. So it's saying what is the length of QR. So we're going to find QR, and as long as you know the coordinates of 2 points, you can find the distance between them. It's effectively using Pythagoras. We simply subtract the x coordinates and square those. So 7 minus 1 squared, and you subtract the y coordinates and square those. So 0 minus 3 squared, just being sure that you pair up the right things. So 7 minus 1 is 6, square that, 36, and 0 minus 3 is minus 3, square that is 9, so 36 plus 9, so it's the square root of 45. Now it has it in the form a root 5, so we want to simplify this third into something root 5. Well, that's fairly easily done. 45 is the same as 5 times 9, so that's the same as root 5 times root 9, and root 9 is obviously 3, so we have 3 root 5. So that's the form that it wanted it in, and therefore a, the constant, equals 3. Now part B wants the equation for this line here, L2, and so we know straight away a point that it passes through Q. So the only other fact that we need about this line is its gradient. And happily we're told that L2 is perpendicular to L1. That's a right angle, so if we know the gradient of L1, that will give us the gradient of L2. So the gradient of L1 is the gradient of the segment from Q to R. Okay, so that gradient is equal to, well, I use y2 minus y1 over x2 minus x1. Remember to get y on top. And the 2 points that I'm using are these 2 points, Q and R. So the y values I'm subtracting, 3 minus 0, and the x values, 1 minus 7. So that's 3 divided by minus 6, which is minus 1/2. So I want the gradient that's perpendicular to that. Okay, so I want the negative reciprocal of that. So my gradient for L2 is equal to minus 1 divided by minus 1/2. Okay, we could write that as minus 1 divided by minus 1/2 if you like. If you don't think that helps, actually I don't think that helps. Let's ditch that. And that can be rewritten as a multiplication, minus 1 times minus 2. Minus 1 times minus 2 is 2. So that is the gradient that we want. That's the gradient of L2, and we know that it passes through Q. So L2 has gradient 2, and it passes through the point 1, 3. So now I just use y minus y1 equals m times x minus x1, and I substitute in x1 is 1, y1 is 3, and m is 2. So y minus 3 is equal to 2 times x minus 1. It doesn't say what particular form it wants the answer in, so I'm just going to tidy it up. I'll probably put it in y equals mx plus c. So y minus 3 equals 2x minus 2, which gives me y equals 2x. If I add the 3 on, 2x plus 1. A note before we move on to part C, compare this to the diagram. It generally says diagram's not accurately drawn, but we can see here that L2 is quite steep, and here it passes through the y-axis at P, at a point above the x-axis. So that fits in with having plus 1 as the intercept. Part C from that is trivial now. The coordinates of P, well, it's the y-intercept, which is plus 1, so it has coordinates 0, 1. You can just write that down, no working required. Now for D, this is the triangle that we're looking at. and I've drawn on the line there, and we have to bear in mind that this, although it doesn't quite look like it, that's a right angle. Okay, right angle triangles are so easy because you just need to know the length of the two perpendicular sides, and then one can be the base and one can be the height. There's nothing complicated here. So we know QR already, we know that was the a root 5, and a turned out to be 3, so that's 3 root 5. So all we need to know is PQ. If we know PQ, then we can multiply by QR, divide by 2, and that's my area. So PQ is equal to, well, Q had coordinates 1, 3, and P, we found out before, had coordinates 0, 1. So using that, the distance from P to Q is difference in the x values squared, so 1 minus 0 squared, plus the difference in the y values, 3 take away 1 squared. So 1 squared is 1, 3 minus 2 is 2, square that, that's 4. So that's root 5. So PQ up here is root 5. So my area is a half times base times height. So it's a half. I'll use PQ as my base. So times root 5. And QR as my height. Times 3 root 5. The root 5 times root 5 gives you 5. Multiply that by 3, it's 15. Divide that by 2, 7.5. Or 15 over 2. And that's your answer. Okay, here we go. Part A of this question. We're given this expression for dy by dx, and we need to show that dy by dx equals this. So we just have to rearrange, basically rearrange that to make it look like that. Looks sort of nasty as a fraction goes at the start, but it isn't really too bad. So let's start with what we're given. Given dy by dx is this, x squared plus 3 over x squared, and don't forget that squared as well. So we have to multiply out the brackets first of all on top. Okay, so x squared times by itself is x to the power 4. X squared times the 3 gives me 3x squared, but I'll have 2 of those. So that's 6x squared, and then 3 times the 3 is 9. And I don't really need those brackets on top, but they're okay there. And that's divided by x squared. Second thing that I can do is I can split that up. Well, I can divide each term on the top by x squared. So x to the power 4 divided by x squared is x squared. 6x squared divided by x squared is 6. And 9 divided by x squared is 9 divided by x squared. But it wants it written like this, and we can see easily that that's what that is. So I can rewrite that as x squared plus 6 plus 9x to the minus 2. Now in part B, well, this is what we've just shown. Okay, and this is a new fact. Okay, a point, we give a specific point that lies on C, and we want an equation for the curve C. So we want y equals something. Now we've got dy by dx. Okay, so if you've got that, y is given by integrating that. So the integral of dy by dx with respect to x, that's what we want to do. We know that differentiation and integration are inverse processes, so integrate to undo the differentiation. So the integral of dy by dx, well, that's going to be the integral of x squared plus 6 plus 9x to the minus 2. Okay, we want to use this form rather than the form we were originally given, because this is something that we can integrate. Okay, so x squared becomes x cubed over 3. You raise the power and divide by the new power. A constant becomes that constant times x, so that's 6x. And 9, well, it's x to the power minus 2, so if you raise the power by 1, you get minus 1 divided by minus 1. And don't forget the plus c. So if we just tidy that slightly, x cubed over 3 plus 6x, the minus sign we can bring in the front, and x to the minus 1 I'm going to write as 1 over x. So 9 times 1 over x is 9 over x. And that's plus c. So that's my general equation for all the curves which have that particular gradient. But we're told something specific about our curve. It has this point on it. So when x is 3, y is 20. So I'm going to substitute those in. So x equals 3, y equals 20, and that will give us the value of c. So 20 equals 3 cubed over 3 plus 6 times 3 minus 9 divided by 3 plus c. So 3 cubed is 27, divided by 3 is 9, plus 18 minus 9 divided by 3, which is 3, plus c. So what that gives me, 9 plus 18 is 27, minus 3 is 24. So 20 equals 24 plus c. So c is minus 4. So my final answer is an expression for y in terms of x. So it has to be all of this, but with the actual value for minus 4. So I'll stick it up here, right at the top. Y equals x cubed over 3 plus 6x minus 9 over x minus 4. And we're done.